So let's take a look at how we would write the molecular, ionic, and net ionic equations for the reaction between calcium nitrate and sodium carbonate. Now, calcium nitrate and sodium carbonate are both aqueous, and they are both soluble ionic compounds. This is a precipitation reaction when you have one salt and another salt. They could switch places. The calcium could end up pairing up with the carbonate, and this nitrate could end up pairing with the sodium. Now, we need to figure out what the formulas for these compounds are. Sodium or calcium will pair up with carbonate. We would get the formula CaCO3. And sodium, which is a plus, would pair up with nitrate, which is an NO3 minus. And we would get NaNO3. Now, just take a second. You might wonder why there were two sodiums and two nitrates on the reactant side. Why didn't I write 2 and 2 as a subscript on the product side? Well, whenever you're doing these kind of reactions, you need to make sure that you're writing down the actual formula. Even though there were two sodiums on one side, we'll take care of that some other way. We can balance that later. But we don't write it as subscripts because sodium nitrate the formula for it doesn't have subscripts of 2's anywhere in it. Now, what we need to do is figure out is one of these a solid. And if you look at your solubility rules, most carbonates are insoluble, so we'd write a solid there. Most nitrates and sodium compounds are soluble. Actually, all of them are, so we'd write an AQ after that. And then, in order to balance it, we could put a 2 outside in front of the sodium nitrate, and then that would make it legal. This is what we call the molecular equation, and that's because all of the species are shown as neutral molecules, even though they're not really molecules, but they are not shown in their ionic state. Now, an ionic equation shows all species that are dissociated in the solution. Now, you have to be careful. Most soluble ionic compounds are shown as dissociated. Most soluble ionic compounds. Most insoluble ionic compounds are not dissociated. So you've just got to keep that in mind. So the calcium nitrate, that's soluble. So we would show that as being broken up as calcium 2 plus. I'm going to write my symbols, states of matter underneath it. And I'm going to get 2 nitrates out of that, which is also aqueous. Sodium carbonate is going to dissociate since it's a soluble ionic compound. I'm going to get 2 sodiums out of that. I'm going to get 1 carbonate. Now, we know to keep the carbonate together because it's one of those polyatomic ions. Now, on the other side, calcium carbonate is a solid. Since it's insoluble, we keep that together as CaCO3 solid. Now, sodium nitrate is dissolved in the water, so that's going to be shown as 2 sodiums and 2 nitrates that are both dissolved in the water. And so this is what we call the ionic equation. Everything that is dissociated in the water 100% is shown as dissociated in the equation. Now, the net ionic is the final equation, and that cancels out any spectator ions. Spectator ions are ions that are just hanging out and not really doing anything. In this problem, it's the nitrate. Notice how it's the same on both sides. Also, the sodium is hanging out on both sides, not really doing a whole lot there. So those would essentially get crossed out in the final equation. And so what we would write down as our net ionic equation is a calcium ion and a carbonate ion going to make a solid precipitate of of calcium carbonate. And that would be your net ionic equation. So